Hello, this is video number 2, part 2 of the sketching of polynomial curves. Now, after knowing our critical points, identifying both the x and the y coordinates, then we're ready to test them, because identifying it to be a critical point is not enough to determine the entire characteristic. We need to identify whether it is a local minimum or a local maximum using the second derivative test. Although we have another test that doesn't require derivative, but this is an easier method, especially if you knew already how to determine higher order derivatives. Alright, knowing the second derivative, we are now ready to test all the critical points. Let's start with point A. Since our second derivative is a function of x only, so just substitute the x coordinate of any point, any critical point, and we are only after the sign. We don't care about the value, the sign. So whenever it is concave, it is negative, then it means concave down. Anything that's negative goes down, right? If you examine closely our vertical axis, as we go down, the numbers became more and more negative. And therefore, if it is concave down as illustrated, and here is our critical point, then that point is actually the highest in that region. You call that the local maximum. That's another important characteristic, so I identified it there. I have placed it there. So that point A is a y-intercept and at the same time a maximum critical point. As I've said, local maximum only. It is the highest point at this particular region, wherein the slope of such point at that peak is of course a horizontal line. So remember the fact that we equated 0 to the derivative just to determine the slope, the x coordinate, and that particular point is a critical point and its slope is 0. Doing the same to point B, we will come up with a positive value of the second derivative. That means the graph at that function is concave upward. And that point right there at the bottom is the local minimum, which is point B. After which, testing for the last critical point, we will come up with the complete characteristic of all the critical points. And we're ready to graph the function. Although, if you still weren't able to determine at least 3 points, you may proceed with the next step, which is the point of inflection. But I'm not going to discuss that anymore, since we already have 3 critical, points to be utilized. So I guess that this ends the second part, and watch out for the third part of this video. Thank you.